All right, so today we're going to use the graphing calculator a little bit. If you don't have one, we'll try to kind of talk around that too. Usually I just say go borrow one, but with COVID and different things, I understand. If you can find an app or any little program where it'll work, you'll be okay, but I will make sure Monday when we talk about the review, I'll tell you what you can do for the test as well. Okay. All right, so let's go. We're going to move on. We're going to do section 3.6. Section 3.6 is Newton's methods. Newton, let's try with an N. Newton's method. Newton's method. And it's kind of all they call it, Newton's method, but it'd probably be helpful to know what it's for, right? So it's for a Newton's method. It approximates roots. Used for approximating roots. What? I know roots, right? We're going to approximate, we got to know what they are. Okay, so another word for roots is zeros. And why do we call them zeros? They're where the graph crosses the x-axis. Wherever the graph crosses the x-axis, you could do something like this. So this one would have, this graph would have 3 zeros, or roots. 3 zeros or roots. What do we know about these guys? Well, the one thing we know for sure is the y value. What's the y value when we're trying to find the roots or the zeros? The y value is 0. That's why we call them zeros. So for these guys, the roots or the zeros, y equals 0. Or remember, you could write it as f of x. Now, not when the derivative is 0. It's a little bit different. But if you had a function, so let's say, I don't know if this is too confusing, just tune it out. But if you had a function, this is f of x, okay, where the derivative is 0. We talked a little bit about this, we kind of got overwhelmed when we were graphing, but where the derivative is 0, when I graphed the derivative, this would go here and this would go here. Does that make sense? Because when I'm graphing the derivative, I'm actually graphing, I know that this derivative is 0, so it would go there. Okay, but for right now, we're just talking about f of x. We're not talking about derivative. All right. So what else do you want to do? Okay. So here's what he says. Let's draw. We're just going to curve it like this. And Newton said, I want to know what this 0 is, but I have no idea what it is. So what he says is, why don't we pick some number out here that's easy to work with? So he says, okay, I'm going to pick this. I'm going to call that x of 1. We're going to go up here, and I'm going to find the tangent line. So this point right here is x1, and then we could say y1, but we're going to write a little bit fancy. Instead of y1, I'm going to write f of x, and then specifically f of x1. So instead of just writing y1, we're going to write it in function notation, and to get this y value, I have to use that x value. And then this one, look at how close where this line crosses the x-axis. I'm getting closer to my root. So now he says, let's do it all over again. So now this is going to be x2. So we're going to go up and we're going to find the tangent line. And look at even just 2 times. Look how close my tangent line is getting to the actual root. Remember, it's just approximating the roots. But I can get pretty close. If I do it maybe 1 more time, I'll get even closer. So every time he starts where this line crosses the x-axis, that's your new x value. So this could be where this crosses. Not only is this a good approximation, but I could go up and use that again. And now look how close I am. And at some point, if you just keep going, they're going to be pretty darn close. If you need it to 3 decimal points, you've got it. And you could probably get it. I think our book asks for 6 decimal points. We can, if we have time, I can show you a little video the lady does. I was looking for a nice computerized one, but I could only find a lady doing it, but she actually does a pretty good job of it. But each time you just take where the line crosses the x-axis, that becomes your new point, and then you start over. All right, let's go through this, and then if we have time, we can do the video. Okay, so how are we going to do this? Well, when I write this on the board, y equals 3x plus 2. What is x and y? X and y is any point on the line. This is any combination that works on this line. I can plug in, so x and y, any point on the line. Let's say I know y. If I know y, I can plug y in and then I could go find x, right? Because it's great that this x2 is an approximation, but I first have to find it, right? And that's what Newton's method is going to help us find x2. Then once I have x2, then I go up, draw my new line. It's great that this green is almost on it, but I have to find that. And that's why the nice thing is, though, they're just on line. So we're going to use the equation of a line. Same with this. When we write this, and this is the one we're going to use, y minus y1 equals mx minus x1. We only plug stuff in for x1, m, and y1. But don't forget, this y and this x is any point on the line. All right, so let's plug that in. Let's do y minus y1. I'm going to write as f of x of 1. Let's leave a blank open for slope. Well, let's do slope. How could I find the slope of this tangent line? What finds me slope of a tangent line? You say derivative. Yeah. So we want the derivative at x of 1. And then we're going to go. Now, you're not going to have to do this every time. I'm just going to show you where the formula comes from. Okay? And then x minus x of 1. And that x of 1 is just going to stay because that's what I happen to label it here. Okay. Technically, this x of 1 is actually this x of 1, so I rewrote it. Okay. Now, what else do I know about this blue point? So this is kind of my equation here. But there's something else I'm going to know. Oh, and I want. Well, okay. Let's talk about this. This guy here. If I want x of 2, that's what I'm looking for. What do I know about the y? The y is 0. The y is 0. So the point that I'm actually looking for, let me write it like this. 0. And then minus f of x of 1 equals the derivative at x of 1. What would I put in for this? This is what I'm looking for, but I'm going to label it x2. and then minus. This is the point that I'm looking for. That's the point that I'm looking for. That's my first approximation of this right. That's my first approximation of that right. I don't know it, except I do know that y is 0. All right, so let's go solve this for x of 2. You don't really need that 0. And the first thing I would do instead of distribute, I would divide by the derivative. Divide by the derivative. Okay, so let's, I can always put up again. So on that left side, I don't need the 0, so I have negative f of x divided by the derivative. And then I've got x of 2 minus x of 1. And then the only other thing I have to do, because I'm looking for x of 2, the only other thing I have to do is add x of 1. Okay, so here it is. X of 1 minus the function divided by the derivative. And then most of the time we write it the other way. X of 2 equals x of 1 minus f of x times the derivative. That guy, well, and we'll write it in more general terms. Okay, so that finds me that second x. Let's even read that. I don't think we need this. Let's make sure we understand what we're finding. Okay, we're trying to find this guy, right? So we pick a point here. This is x of 1. We just randomly pick it. We go up here. We draw the tangent. And now I just found this point right here. That's x of 2. That is x of 2. So now what do? I want to do it again. So I go up, find the tangent, and now what did I just find? I found x of 3. X of 3. Guess, so that I don't have to do this all over again, guess how I can find x of 3. What point does this red line start off with? This red line starts off with this point right here, which is x of 2. So to find x of 3, I just do x of 2 minus f of x of 2 divided by the derivative at x2. My next one would start, I would be finding x of 4, but I would be starting with x of 3. So x of 4 starts with or correlates to the third value that I found. So to write it fancy, this is how we write it, and then we'll box it. To find x of n plus 1, so I want one more, I do everything with x of n. Okay, so that's Newton's method of finding roots. So if I want the first one, I'll plug in 1s here, and that's just the same x sub 1. And then that'll give me, I plug a 1 in here, but that will give me x sub 2. If I do it with my second point, or my second x value, x sub 2, then I'll put a 2 in here, but I'm actually going to get the third x value. All right. So let's try one. All right, so it says, and these are the directions, starting with x sub 1 equals 2. Find the third approximation. Find the third approximation, which is x sub 3. Okay. We'll consider this one the very first approximation. So they actually gave us the first approximation. So we have to find the second and then use the second to go find the third. Find the third approximation for the root of, and then here we go, x to the third minus 2x minus 5 equals 0. So, and I don't have to call up the calculator for this. Let me just graph it. X to the third minus 2x minus 5. All right, and so this graph so this graph, if I graphed this, it does something like this. It curves like this and then crosses here. So I'm trying to find this root right here. Where am I going to start out?
A little bit over to the right.
Yes, yeah, and actually I think this actually has a start out, and you can start out anywhere. This one actually has a start out. 2 is actually right here, a little bit to the left. Okay. Which actually makes maybe some sense, because if I come down here, where's my, you see how this would be my tangent line? And now I'm going from here. And you can go up or down, that's okay. Maybe I'll show the video because she does it really good. She has up or down. I will say this though, it doesn't work 100% of the time. Okay, there's just some times where your tangent lines will get skewed off and it just doesn't work. But most of the time, especially if you're pretty close, 2 is pretty close to our answer. So we're going to be okay, but it does not work 100% of the time. Okay, so we're trying to find this blue dot right here. Or at least approximate it, Now this is how our book does it, so we'll go with it, but I like to give it to you as a function. Because if I say, it kind of just reminds me, if I say find the roots, what do we know? The y value is 0, okay? So if they give it to you as a function, oh, maybe later on they do. Let's see, I think one of our examples, no, okay. But if they give it to it as a function and they say find the root, it kind of reminds you what you're doing, especially if you don't see the graph. Your y value is 0. Your root, the y value must be 0. And so do you see how that turned out to be the same thing? They kind of put the 0 in for us, which I guess was nice. But if they just give you a function and they say find the roots, 0 goes in for your y. That's the one thing you know. Okay, so now to find, we'll leave a little bit of space there, to find our first approximation. Well, our first approximation is 2, because 2 and our actual blue dot are not the same. So to find our second approximation, we're going to do x of 1 minus f of x of 1 divided by the derivative. And what is x of 1? They want us to start with 2. So we are going to have to do x of 2 is equal to 2 minus f of 2 and then the derivative. And that 2 is coming right from it. And so now we just have to go at it. Now we have the function, but we need its derivative. So go off to the side, find its derivative. So roll it down, subtract 1, 3x squared. Roll it down, subtract 1, negative 2, and then negative 5 goes away. Okay, so now this is why I think this kind of turns into a calculator. We need to do 2 minus my f function, but I'm plugging in a 2. So 2 to the third minus 2 times 2 minus 5. And then over, now I plug in 2, but I plug it into the derivative. I'm going to do, and make sure that you don't lose this minus. And then I do the derivative, 3 times 2 squared minus. That's probably, I don't know. Yeah, it's a little, it's okay. So this gives us, this is going to give us x up to 2 minus, and that should actually be negative 1/10. So this is 8 minus 4 minus 5. So that would be negative 1. And then the bottom is 12. This would be 4 times 3 minus 2. So this is 12 minus 2. So that should be 10. And again, if you just want to type that in, that's fine. So the top should actually be negative. Bottom is negative 1. The bottom is 10. But you also have this. So the two negatives in a row give you plus 1/10. We love fractions in higher math, but we're going to get to decimals really quick. So it is more than okay to do 2.1. And actually kind of look at this. We started out, now this one started out, we started out at 2, and look where this took us. Now we found this value, which is actually 2.1, right? So what does that even tell you? Now, sometimes all of a sudden the lines get going, but I think that our answer is somewhere between 2 and 2.1. So even there, we kind of got lucky. 2 is pretty close, but we already have a good approximation. And we could split the difference, 2.05, and we're probably pretty close. All right, so let's find the third though. Let's do the third. Let's do this. So now to find the third approximation, and for this example, the final approximation, I do x of 2 minus f of x of 2 divided by the derivative using x of 2. And so now I just do x of 3, my third and final approximation, 2.1 minus f of 2.1 divided by the derivative using 2.1. And then we'll just take time with the calculator. Plugging in 2.1 into my original function. So 2.1 to the third minus 2 times 2.1 minus 5, and then divided by the derivative, plugging in 2.1. 3, 2.1 squared minus. I left this as 2.1. I did it separately, so I did the numerator, to the denominator. I got 0.061 over 11.23. And I'll be honest, I don't know if I rounded those. Should I do? I can even do the 2.1 times. I'll do the bottom. So that's exact. I did not round that. So probably the top, the same thing. 2.1 to the third. Sometimes you might have to round. Oh, 2.1 to the third. And then minus 2 times 2.1 minus 5. Yeah, okay, that was, okay, so I didn't have to round either one of those. So those are exact values. So divide that out, 2.1 minus that. I got something like, so 2.1 minus this fraction. I got something like 2.0946. So something like 2.0. I think maybe it said something to round to 3 places. So this 6. Now, if I wanted the fourth one, what number would I have to use? If I wanted the fourth one, I would have to use this number. And I think this one kept going. Okay, so rounding it is going to change it a little bit. But in general, I could now use this because this is the third. Right? If I wanted to, I could use my formula again, plugging in 2.095. Okay. Let's see. Let's start it off for those who don't have calculators, and then we'll talk about, there's even a shorter way to do it with the graphing calculator. Do you have a graphing calculator? Okay. Don't pay if you don't. It's okay if you don't. It's just kind of cool to see. All right, so let's start it out, and then we'll switch. That way, this next problem will kind of encompass both. Okay. Because, and this is like, it's like, okay, that was doable, but is this, yeah, this one, it's so nice to have it calculated. All right, so use Newton's method. It's up to you if you want to write this. Use Newton's method. We could use Newton's method and x of 1. Okay, so they're going to give us that. To approximate the root to 6 decimal places. So if they have you find x of 3, it's not too bad if you don't have a graphing calculator. If you don't have a graphing calculator, then this 6 decimal places is a lot harder. So on the test, I think I'll have like one of each, so then you can pick. So we'll talk about that more on Monday. Let's see. I think that should do it. Okay, so let's, and then they give us a crazy 2/5. 2/5 x to the 5th plus 1/4 x to the 4th minus 2 equals 0. And then they'll tell us, they want us to, the first approximation is 1. Okay, so now remember, and this might help because our formula does use f of x. So don't forget that this equation is f of x. And then they put in a 0 for f of x, or they put in a 0 for y, because that is where the roots are. So just remember they did it for us, but it might be nice to write it back because our formula does call for the function. Right? So this is our function. They put in a 0 for y, and that's a good idea because that's where your roots are. I'm rewriting this, but that's okay. But just so you kind of see how that all goes together. But we might want to write it as f of x because the other thing it calls for is the derivative. So it was a little messy, but what is the derivative? When we roll it down, the 5s will cancel, and so we'll have 2x to the 4th. When we roll this down, 1/4 times 4 is 1. And then we just subtract 1, so x to the 3rd, and then the minus 2 goes away. So 2/5. Remember, we roll it down, so it's 5. I can make it 5 over 1. That should just give us 2. Right? And then the 1/4, when you roll that exponent down, you multiply. So at least they get something a little bit nicer. So let's do this off. Now, the first one isn't too bad. We're going to find x sub 2, and we're going to do that by doing x sub 1 minus f of x sub 1 divided by the derivative. And what is x sub 1? 1. So that's kind of cool too. Yeah, and that's what they gave us. So x sub 2 equals 1 minus, did I erase it? No. So now I do 2/5 x, but x is 1 to the 5th, plus 1/4, 1 to the 4th, minus 2. And then not all over, but just this part, because you still have the 1 minus. 2, 1 to the 4th, plus 1 to the 3rd. If you want to change this, like 2/5, if you want to change that to 0.4 and change 1/4 to 0.25, this is definitely a decimal. So if you like decimals, you can definitely use that. Remember, this fraction, you still have the 1 minus. But even this answer is crazy. All right, depending how you even do this, it doesn't turn out to be very nice right away. It turns out to be something like 1.309625. So now, if I want to do it again, I got to use this whole number. And I got to go until 6 decimal places are the same. So we're going to use, that's when we would use our calculator. So let's take a look. At least walk through it if you don't have a calculator. I'm going to try, let's see. I'm going to do a new share. Okay. Okay, you guys can see that. All right, so you guys out there, you're gonna have to listen. Here's what we're gonna do. We want to, you go to y equals, and if you have anything there, clear it out. So you just hit clear, and it goes away. All those good equations are gone. And in y sub 1, you are going to type, what equations are we using? You're going to type f of x, and then y sub 2, you're going to type the derivative. Those are the 2 equations that we're using. So in y sub 1, I'm just going to type the original function. So it was 1/5, and then x to the 5th.
It is 2/5.
2/5. Oh, dear. I was going to wait and then turn, and I got the very first turn. Beautiful. Okay, 2/5. Good. Okay, so yeah, make sure that you know. Good. That at least that means you know where I'm getting it from. Very good. Okay, so 2/5. Okay, good. Okay, 2/5 x to the 5th. All right, good. Plus, and if you want to do 0.25, you could. Otherwise, we could do 1/4. It's okay to do decimals. You just, if it's 1/3, you don't want to do like a couple 3s. you then put it in as exactly 1/3. X to the 4th, and then -2. All right, and then this one is the derivative. Y2 is the derivative. So let me look, 2x to the 4th, and then plus x to the 3rd. I don't think, if this does not work, I don't know if do I need the 2/5 in parentheses? I don't think so, but if things go awry, then we'll just go back and put that in. All right, so you put, I know you guys can't see me in TV land, but y sub 1 is f of x, and y sub 2 is the derivative. Okay, then you go to your home screen. So now we're going to do everything else on the home screen. So you do second mode, which is actually quit, and it takes you kind of right there. It's kind of holding those y values out in limbo. I call it the home screen second mode. Quit and just get to your home screen. Or I think if you just, well, no. Yeah. Okay, so the first thing you want to do is you want to go down to right above on. Oh no, you want to first hit X. X, store is right above on, and we want it to be 1 because of this right here. X of 1, they let us equal 1. Okay, so the store key, that little arrow key is, I think, is it just STO? All right, STO, but it's right above the on key. Okay, and then we hit enter. Oh dear, that's not good. Oh, is it 1 store for X? Oh, maybe it's 1 store for X. Hang on, let me see. Okay, hang on, clear that out. Let's try. I think is it 1 store for X? Did I do it backwards? I'm dyslexic. Yes, okay. So back that up. Try it again. You could just clear it out or whatever. It has to be 1, and then we have to store that for X. Okay. Did we see that or no? So take your time. Holler if you didn't get that. And then it's kind of nice if you hit enter, it'll show that 1's in there. You can even you can just watch if you want. If I type now X plus 3, and this is not part of the problem, I'm just telling you. Does anyone know what I'll get for an answer? I'll get 4. Because what is it going to do? It's going to take, X is now 1. X is now 1, so it's going to take the 1, plug it in there, and then do the other thing. It thinks every time I do X, it thinks that it's 1. So there it is. Okay. If I want to change it, and you could just watch, if I want, and I'll make sure I do it right, 2 store for X. Now what does it think? It thinks it is 2. So now my answer would be 5, right? Now I could type X plus 3 in again, or if I just do second enter, it tells me that's the last thing I did. But if I just leave it right there and I do second enter again, it just goes backwards. There it is. So now, could it have just been easy enough to type in X plus 3 again? Yeah, but if you do second enter and you just keep doing it, it just keeps going backwards. Okay, so now it thinks it's 2. So now when I hit enter, there's my 5. All right, so I want to go back to 1 store for X. All right, now we want to tell it to do this. So we want to tell it to do X minus, and then I got to tell it, what did I put in for f of X? I put that into Y1. So here's where there's 2 places to go find Y1. The one place you have to go is vars, which really stands for variable. So find the key VARS, which is, where is it? Kind of just south of the down arrow. Okay, so you go to variables. And which of these do you think we want? We typed it under y equals. So we want the y variable. Oh, no. So I think I have to use my arrows. There we go, y variables. It's a function, so that everything, the function is highlighted. So I just hit enter. And there is y1. And then I want to divide. Now don't hit enter yet. I want to divide. I want to divide it by the derivative. Where was the derivative? y2. So here we go again. Variables. It's a y variable. So I use my arrow key to go to y variables. It's a function. So I just hit enter. And then I want to go down, or I could hit 2. I want y2 because that's where the derivative is. Now, if I hit enter, don't hit enter yet, I'm going to get this answer, 1.309625. But not only do I want that answer, but I want it to be my new x value, right? Because the second time around, now I would use this. So I'm going to store this answer for x. That's key. So it's going to give me the answer, but that will become my new x value. So now when I hit enter, well, that's not good. Why did it give me that? I don't know. Did I type something in wrong? Oh man, I was all excited. I wonder if do I need parentheses? Remember I said if it goes awry, I need parentheses. I don't think I do though. Well, let's stick them in. All right, insert parentheses. Oh my goodness. Let's see if this makes a difference. Does anyone know, do I need parentheses? I did not think I did. Did I type it in okay? Oh, goodness, I'm so disappointed. All right. Go figure. Oh, my. I'm worried because I don't think this is going to make a difference.
Do you have to switch the modes from like degree or radian or something?
No, but good call. It should be okay. All right. 1 star for x. Maybe did I write down the wrong number? Oh, biscuit. I wrote down the wrong number. This should actually be 1.45. So we were okay. That should actually be 1.45. I was just looking at the wrong spot. And that makes sense, because that should actually, I mean, yeah, that makes a lot of sense. Change that up. And we'll bring it back. Actually, that makes sense. Shoot, that makes sense. So x to the third, let's at least write it. X to the third, 1 minus 2/5, and I know you guys can see me, 1.45 to the 5th, plus 1/4 to the 1.45 to the 4th minus 2, and then all over 2, 1.45 to the 4th plus 1.45 to the 3rd. And then at least if you don't have your calculator, you'll be able to get this. And that was that number that I wrote down. What did I write down? I wrote that one. 1.309625. Does that make sense? Or we've lost you? All right, so at least, yeah, this one, I'll show those guys in a minute. Okay, so let's see. All right, so let's try this. All right, so I like the 1.45. Okay, so let me do this. Okay, now I'm going to do second enter. That's my fault. Obviously, right? Okay, so if I hit enter, I get 1.45. Okay, and that's okay. So let's make sure we're all there. All I have to do, what is X now? X is now 1.45. All I have to do is hit enter, and it does it again. And there is my 1.309625. So that is my third. This is my first approximation. This is my third approximation. All I have to do now is hit enter, because what is it using for X? It is using the 1.309623964. All I have to do is hit enter, and that is my, so this is 1 was my first, 2 was 1.45 is my second, third, fourth, and I just keep hitting enter until 6 decimal places line up. And there it is, right? So this is 1, 2, 3, 4, 5, 6. I could have even done it here. 1, 2, 3, 4, 5. Oh, even these two look different. I know you can only see the top, but so it's kind of like right here. And so that's your answer. You just keep hitting enter until 6 decimal places pop up. So it is 1.27385, 5, and then 3, but then there's an 8 after it. So that would cause that to go to a 4. And that's your 6 decimals of approximation. Let's try one more. But now that we've got this, I think let's. Yeah, that's right. Let's stop there. Let's do, well, let's just do this. For homework, let's at least try it. We should have time tomorrow because tomorrow's lesson is actually important, but it's not too long. So I'm going to leave today's up. I could even maybe cut some of tomorrow's off. So see if you can do 1, 2, 1, and 2. 1 and 2. And actually that'll be okay because 1 is to the third, x to the third. So, and it's 2x to the third as well. Yeah, and that one's x to the third. All right, so you're going to try 1 and 2. And you should be able to do 1 and 2 if you don't have a graphing calculator. If you want to use this, you can. And if you get stuck, then let me know. We can look at it really quick tomorrow because it won't take that long. Okay. All right. All right, we should be okay though. Let's let me come back here for you guys. Let me show you guys. This is what this x sub 2 should have actually been 1.45, and then x sub 3 is this guy. Did I erase it? What was our, did I erase that middle? Oh yeah, because I was going to start that other problem. That other was to 6 decimal places. Let me just write this one up there. 1.27385, and then this 3 rounds to the 4, and that's your 6 decimal. I'm gonna stop recording, but if you out there